Okay, this is a problem from section 4.2 in our textbook. We're given a differential equation, dy dx equals x times the square root of x squared plus 5. The question asks us to solve for y, given that when x equals 2, y equals 12. So we're going to take the antiderivative here. So a little manipulation leaves us with dy equals x times the square root of x squared plus 5 dx. And then from here, we will take the antiderivative of both sides. Let me clear that up a little bit there. And then on the right side, where we're going to take the antiderivative, we're going to need to do some u substitution. So u is going to be x squared plus 5. That means du is 2x dx. And notice in our integrand we have an x dx. So we have that factor of 2, so we're going to multiply both sides by 1/2. And that leaves us with 1/2 du equals x dx. So now doing our u substitution, that leaves us with 1/2 the integral of u to the 1/2 du. So x dx is equivalent to the 1/2 du. There's our 1/2 du. And then u is the x squared plus 5, and the square root, we just write it as u to the 1/2 so that we can use our power rule. Let's see here, there we go, that's much better. So now the antiderivative of dy will be y equals, and on the right side we'll have 1/2, and then the antiderivative here will be u to the 3/2 divided by 3/2 plus c. And yes, technically you could have a plus c here and a plus c here, but that would just be a constant plus a constant, which is another constant. So that leaves us y equals, take the reciprocal and multiply, and that leaves us with 1/3. We're going to resubstitute back in our x squared plus 5 for u. And now we're going to use this condition that when y is, when x is 2, y is 12 to solve for c. So we'll substitute 12 for y. We'll substitute 2 for x. And here we have 2 squared is 4 plus 5 is 9. The new denominator here, the 2 tells us to take the square root. Square root of 9 is 3. 3 cubed is 27. So 9 to the 3/2 is 27 times 1/3 is 9. Subtract 9. C is 3. So that leaves us now with our equation is y equals 1/3 x squared plus 5 to the 3/2 plus 3. And this satisfies both of these conditions up here. When x is 2, y would be 12. And if we were to take the derivative of this equation, we'd end up back to here.